Okay. So everybody's there. Good. I just want to give you another detail now. Let's suppose that you wanted to put the file in another directory and not documents. There is a way to tell R where R should look for the file, and this means giving the path of the file. The first, but you need to know the path. So let's suppose that you placed it in whatever position. You should right-click on the file name. So you get your file manager in Windows, you right-click on the file name, and you look for properties. And in Mac, there should be something similar. Under properties, you get the full path of the file, which in your case, in your current case, should be something like C, and then users, your name, your username, documents. So the alternative solution is to give to R the full path. Like what I can do myself, given that I put it in a different path, is polyverflow is equal to scan, and I give him the full path, which is different in my case, is your home. And while you give the path, you can complete it with the tab. And then I can, this is my path, and you see that it finds it. It finds it. So, again, you need to know the path, and you can make this experiment now. I suggest you to do it. And be careful. When you write the path, you may start by writing. What you have to do is to do this, C. And then, can you remind me what is the name, is double comma, what is the name of this? No, not quotation, it's the two dots. The two dots. You see there? Semicolon, semicolon, yeah, semicolon. So C, semicolon, and then you have to use not the slash, but this sign which is the revert of the slash, okay? If you want to use the slash, you have to put it twice. And then users, be careful of the capital letters, check with the tab if you can find it. Okay, users, and then you have to put your name, and then documents. And then ponte largo scuro, etc. Try to do it, because it's a way to get familiar with playing with the path in your PC. Let's take a couple of minutes to play with it. Of course, you should know the path in advance, because this is just a suggestion. Maybe that it's not C users, it's a different path. In order to find it, you have to, again, with File Manager, right-click Properties. Okay, now let's move forward. If you didn't succeed in this exercise of finding paths, etc., please practice at home, okay? Practice at home in order to get a full comprehension of how to find a file in a PC, in whatever path, okay? Now, given that you all succeeded in uploading the file, let's see what is the situation now. First of all, the file is, just one second, the file is uploaded as a vector What is a vector in R is something that we didn't discuss yet. We discussed about variables, so I said A equal 2, and then if I write A, I get the number 2. Now, in R, we can also define vectors. Let's see how to define a vector. Before starting playing with the vector that we just uploaded with the Poriver flows, let's learn how to define a vector. The vector can be defined in this way, through a function. The function is called C, and the argument is given by the elements of the vector. If I type A now, I get the vector. Of course, you can put any number you wish, and the length of the vector is unlimited. Now, we can make operations with the vectors, like A times 2, A plus 10, and you see what happens. The operation is performed over each element of the vector. Okay, now let's look at our vector of the Poriver. First of all, let's not to display it. Just 1 second, because I don't remember how I Poriver flow. Let's not to display it, because if you display it, what happens is that you get a sequence of 32,000 numbers, and this is not useful. Okay? But we can play with the vector, for instance, by looking at the max. Let me do it again, sorry. And you should get something like 9,780. And then you can take the minimum. The minimum is 168. And then you could compute the average. The average is extremely important, because the average flow gives an important indication on the river flow regime. Max also gives an important indication. Min is an important indication. What I'm doing now, we are playing with R, but actually from a technical point of view, what we are doing now is to inspect, to analyze the essential behavior of the river flow regime. The max flow, the mean flow, the average flow, these are essential behavior to understand a river. So once you are given numbers, the first thing that you should do is to understand the behavior of the river that is behind the numbers. So the average is computed through the function mean. So this is the average flow of the Poriver, 1500 cubic meters per second. It is something that you have to keep in mind, because it's an important order of magnitude. Now, another important indicator of the river flow regime is the variability, because the average is a central tendency. Like, I hope you understand me. The average flow is an indication of a kind of mean behavior, but the river flow is fluctuating around the average, and the higher the variability, the higher the fluctuation around the average. If the variability is 0, you get a constant around the average. For increasing variability, you get more fluctuations. And when you talk about water resources availability, variability is extremely important. How is variability quantified? Through the standard deviation, something that you remember from your background. You learned what is an average or mean. You learned what is the standard deviation. Okay, standard deviation in R is computed through the function SD. It's 1000 of standard deviation. It's a lot. When the variability, standard deviation, is same order of magnitude of the average, it means that there is quite a substantial variability. In fact, we saw that the river flow is fluctuating between the minimum 168 to the max that is almost 10,000, so there is a lot of variability. Variability is something that for a water resources management is not good. For a water resources manager, it's not good because ideally, in order to minimize uncertainty, we would like to get the same flow in a steady state condition. In this case, it's not like that. Okay, now to conclude for today, there is another important indication of the river flow regime, which is the plot. Now, let's see how in R we can get a plot. This is actually very easy. I anticipate that the plot of a series that is 30,000 long, it's a messy plot. So we don't have to expect to find a very good indication from this plot. But in any case, let's see at it. The plot is the first thing that you should make, drawing a plot, when you get numbers, because it allows you to get an overall picture. Okay, so it's very simple. Plot for river, but let's give another argument. Tide equal line between quotation, because in this case the plot is not a dotted plot, but a line plot. If you don't put the argument type, it's a dotted plot. Now, if you press return, you get another window opened with this plot. Yeah.
Why did we put the other argument?
Sorry, say again, the second argument you said?
Why did we put the other second argument?
Because look, if you don't put it, you get this one. It's a dotted.
Ah, okay, it's
okay.
Okay, thanks.
That's it for today. If you have any question,